Hey everybody, so this is the Wednesday, September 29th, 2021 SIG Auth meeting. Pretty light agenda today, but let's go ahead and get started. Can y'all see my screen? Am I still screen sharing? I lost a little side thing. All right, Nish, did you want to talk about your retroactive cap?
Yeah, so I added this to the agenda last week. So Rita has been helping review the PR. She added a couple of comments and we've been responding to that. So I just wanted to bring it up again in the agenda so we can get more reviews. Also, in terms of the releases, we actually got a release candidate for the driver this week. And then we're going to publish an official image after the KEP is merged. So I just wanted to put it on the agenda again and ask for more reviews so we can get merged.
Cool. So I think I saw the comment where you said you guys were working towards a release candidate for like 1.0. Is this kept sort of in line with that 1.0 state?
Yes.
So I think Mike had said he would look over this from like a SIG Auth perspective. Are we hoping to use that review as a like I know Mike, you're on the call, like so if like Mike read it and was happy and like approved it in whatever sense you approve a already done thing.
So this is actually a driver implementation, or is it part of the central infrastructure?
No, this is all just the driver. So we didn't have a KEP when we actually migrated the project as a sub-project. So this adds that and then also goes a little bit deeper on what metrics and all those we have in terms of the features, and then basically talking about graduation to GA. And then we are hoping to use this process as we make further changes as well.
Would it be helpful to have an initial drop that captures the current state in like a beta level or pre-GA level, and then just a snapshot like what we already have, and then have like the changes or GA stuff like as a follow-up?
So this KEP should have all of it. So we try to go back all the way to where we started, and then like we talked about alpha and beta, and then right now we have a release candidate for pre-GA. So it goes over all of those, but if the preference is to split it into two different, so we can get the retroactive in and then just have another one for just the GA updates, then we can do that as well.
I mean, if it's all retroactive, it probably doesn't matter. I couldn't tell if you were saying it was trying to capture current state and then also describe future changes that were going to be made on the way to GA, but it sounds like it's all retroactive.
Yeah.
Okay.
Yeah, that sounds good. Is it like in LGTM state from the perspective of the project leads?
I reviewed it. I think it's really, really close from my perspective, but like Anish mentioned, it would be good to get at least one more review.
Yeah. That sounds good. I will. I can do the additional review. I think I have context from the earlier reviews I did, and yeah, it sounds like that's ready to go.
So just for clarity, so let's say so Rita, let's say you finish your review and you get all your desires addressed, and same with Mike, and we let's say we merge the KEP. Are we calling that a formal +1 API review from SIG Auth, meaning that if you then ship the 1.0 release as a basically, are we saying that the 1.0 release that comes after this that meets whatever is in the final state of this KEP, is that a GA'd API? Are you sort of following that? Like, I realize it's a sub-project and that maybe doesn't have the same exact conventions as Kubernetes core, but I'm trying to understand what we intend for an external party to observe from this 1.0 release. Like, what are they getting? Are they getting a stability guarantee?
Yeah, in terms of how we have designed, written the KEP, it's around the core functionality, right? Rather than focusing on the API aspects, because CRDs was something that we added later, but we have focused more on the core functionality. And then in terms of issues, how can you recover? And then like try to add metrics. So like we went a little bit over the PRD aspect of it. So it's around how to enable it, disable it, and then debug in terms of errors and what the core functionality is.
Okay, so then a related question. What version are your CRD APIs today?
They're actually at V1 Alpha 1.
Okay. For the 1.0 release, does that mean they go beta or GA? Does that change anything?
Not for the 1.0, but we are thinking about few changes in terms of the CRDs post 1.0. So we're going to look at graduating the API post 1.0, like going to a beta API and then a V1.
Okay.
So this 1.0 release is for the core functionality of the driver in terms of the volume mount and what it supports.
Does that driver communicate with the CRD APIs? The alpha APIs?
It does.
Okay.
That's kind of strange, right? Because that means if you start ripping apart the CRD APIs because you don't like them anymore, then you're changing the semantics of what the 1.0 stable thing has to do to understand them, right?
Yeah.
So maybe.
Go ahead.
Sorry, just maybe another way to ask this is like, do we feel like in order for this sub-project to graduate, the core APIs have to be in V1? Should that be a recommendation?
I mean, if you make a 1.0 release and all your APIs are not V1, I don't know what it means.
Well, I mean, so I think it is definitely a recommendation. However, like there is precedence for GA features depending on at least beta APIs. I don't know about alpha.
Is that true?
That is true. Kubelet certificate rotation has been GA for a very long time, and
we GA'd that when the API went to V1.
It was in the beta state for forever because CSR was in beta state forever.
Specifically for that reason.
Really?
Yeah.
I mean, beta is the new GA, so.
What about, so not rotation, sorry, Bootstrap, Kubelet TLS Bootstrap.
I'll have to look. I think the question is more like from a user perspective. If we say this thing is stable, like it's 1.0, but it has a dependency on an alpha API, can we really, like, does that mean we effectively have to treat the alpha API as like a more supported, more stable thing than it maybe actually is? Or we have to keep it around forever because removing it would break this 1.0 version that we said was stable? That's what I would really focus on,
right,
rather than like policy or can we do it? Like if someone says, oh, great, this is stable, I'm going to install this and I expect it to keep working like forever-ish. Can we really make that promise if under the covers you have to have this alpha level thing, which we know we want to progress to beta and progress to V1, and I would expect we would not want to support the alpha API forever. And once the V1 is there, we would like try to shift usage onto it. Yeah, that seems kind of strange. Is there a reason not to wait until the APIs that underlie it reach stable before tagging as V1? Like, what's the motivation for marking the component as V1 before the APIs reach stable?
So I think it's mostly in terms of usage. Like users actually want a GA implementation of the driver. And then like custom resources was something, initially when we started off, all the metadata that was required for the volume mount was provided part of the pod spec itself, right? And then to support pod portability, we basically added these custom resources and then switched over to having the user configure that through custom resources. So the 1.0, we are trying to say that the APIs will not change. Like, I mean, I think what you said, right? Like the alpha APIs is very close to what we can call beta today. But in terms of the functionality, we can say that it's well tested, load tested, and then like it works well. Like that's what we're trying to say with GA for the drivers.
Yeah, I think we would just want to avoid a situation where we would say you have to upgrade your 1.0 secret store because it's going to stop working because the alpha API is graduated. Like that doesn't seem like a good situation.
I think another thing to mention also is the API will change for certain features. So though the driver may go to V1 or GA, I think the core functionalities, the APIs should be also graduating. However, the specific features, they may not be going to V1 because some of these are still being tested, or it's a feature flag that people can turn on and off, whereby then go ahead.
That can be okay. Like if a particular field in the API, like you have to enable, but like which endpoint we even talk to, that's pretty breaking. If we say like the V1 expects to talk to the alpha endpoints, and if those aren't there, then it's non-functional. And later when we move to beta or V1 endpoints, like we expect the driver to talk to those instead. Like that's very breaking, as opposed to like, we got the API info and there's like this one feature in the API object that may be on or off, like depending on feature gates. Like rolling those out in a controlled way makes sense. And that's an easier story to say, like, there are these features in the pipeline, and if you want those, you need to update your driver from 1.0 to 1.1 or 2.0 or whatever. Like upgrade to get new features is a much more normal story and easier to sell than upgrade to avoid breaking what was previously working, because the APIs are no longer alpha, they're now beta or V1.
So if I could, as a suggestion, and I'm trying not to be prescriptive here, it's just sort of a thought exercise. Before you guys do a 1.0 release, would it be possible for you to go through your custom resource-based APIs, your CRDs, and effectively make the changes that you want to make, and basically make a V1 release with the changes that you believe to be good today, right? And basically, if you need a conversion webhook, you probably have to write that, but get that sort of in place and rely on the V1 API. And then basically you have two choices after that. You can expand that API over time very carefully, sort of following what you would expect a V1 API to do, or you could build a brand new V2 API that starts off in alpha, iterate on it, and then, you know, at some maybe 2.0 release, you'll say that, hey, we're done with the V2 CRD based API now. And the 2.0 release requires the V2. It does not sort of, like, to me, it's just very strange, but basically just the different way of saying what Jordan said is that it's totally fine to expand a V1 API in a backwards compatible way. And, you know, it could have fields that are inert when feature flags are not enabled. You know, the CSR API has those, right? CSR v1 has expiration seconds or whatever on it, right? That's a beta feature flag API. If you turn the feature flag off, that field becomes inert. So that's all totally fine, but we're not going to break the CSR v1 API, right? We might add features to it. We might one day do a CSR v2, maybe.
So what you're describing as the primary motivation for tagging this as V1, which is like consumers' desire to have a stable, supported component version. I think is a good indication that the dependencies of this thing also need to be at a stable supported level for us to actually be able to make that promise to people that consume this.
Okay. Yeah, that sounds good. I can bring this up in our community call tomorrow, and then we can make a decision on how we want to proceed.
Thanks.
Cool. We can continue this discussion next time too, if you guys have feedback or concerns or whatever. Awesome. Does anyone else have anything on this before we move to the CAP 2799 discussion? Open it.
Just as a note, I think it's totally fine to merge the retroactive CAP, and if you want to fold some of this into that as like, here's the roadmap to GA, and if it's a short list, which currently consists of like get the API stable, that's fine. Like capturing this, I think is great.
Okay, yeah, that sounds good.
Also, thank you for writing the retroactive CAP. I really appreciate those. And I also really appreciate people that keep existing CAPs up to date. So that way they serve as a nice reference point for like understanding what the system does without reading the entire code base. All right. Shihan, are you here?
Yes. We talked about this in the previous SIG Auth meeting, which at that time it's ambiguous. Ambitious that we try to deprecate the token controller, but after the reviews, we make the scope smaller. Basically, we only focus on the auto-generated tokens. So there are two actions. Just a summary, there are two actions in this CAP. One is stop auto-generating secret-based tokens, and the second is remove unused auto-generated tokens. So just bring it up here to get more attention on this. The sooner that we can get this in and the fewer Nexus tokens exist.
If I could ask a question on, does this, so I had seen the comment by Clayton and I haven't had a chance to read it again, but does this, does the current state of the proposal state that we will make it so that if you make a secret with the correct annotation that the token controller is supposed to fill in, are we saying that we're going to break that, or are we saying we're going to keep that working?
You mean the auto-generated token?
Not auto-generated, manually requested.
Okay, we still keep that functionality.
Okay, is there any plans on ever breaking that functionality? I'm trying to understand, like, the perspective I have is, I'm very sympathetic to users that have use of this, and also as a user of that functionality, primarily because I have to support both new and old Kubernetes versions. So I don't have the luxury of necessarily not only using bound service account tokens. I have to basically support both worlds at the same time. So this is
yes, for the managed create tokens, they are not in the scope of this CAP for now, I think, because we don't have alternative for the manually created, like non-expiring tokens.
David, you muted a few times, so if you want.
Yeah, I'm curious how you are going to detect and indicate that a particular token has been used. I like the idea of saying, if this one's been used in the past 3 months, I better not delete it. But I'm not sure how you determine that in the API.
Annotating secrets that have been used with a pretty coarse-grained indicator, like the date they were used, so that they get written to at most once a day. So the API server has both the secret at hand and knows when it was used to authenticate.
Okay.
And then you can query that. It's visible in the API, so you can locate them if you want to eliminate that usage. You can audit them, and then the controller can use that information at a defined time interval, which I would expect the cluster admin to be able to control, to say, clean up tokens, auto-generated tokens that haven't been used in X time period.
Yeah, that'll work. I guess once a day is fine with me. And would that include usages where someone said, is this token valid? I guess it has to, even though it wouldn't be on the authentication chain. But I can imagine using that for, is this token valid? Someone presented it to me.
Calling a token review calls the authenticator, so I would expect it to exercise it and annotate it.
Okay.
That's a good point. We should make that decision intentionally, but I think by default, if this got queued up from inside the guts of the authenticator, I think it would work, but that's a good
so I'm going to say
test.
that's the thing I need to have work.
Yeah.
So in a related question to that, are we, I think the answer is yes, but so we're fully comfortable with basically read level actions, like just general use of a token for read level actions, as well as indirect read level actions like token review causing a mutation on the back end. I think it's fine. I just want to.
A token review is effectively a delegated authentication.
Yes.
So
it is what it, that's exactly what it is. Not effective. It's literally what it is.
Yes, we don't want to break people talking directly to the Kube API server, but we also don't want to break people who were using the authentication mechanism we gave them to do delegated authentication somewhere else. Yeah.
Okay. So I think I saw Jordan, you had a comment on there that this is slated for 124 as an alpha. We'll start working on that.
Yeah.
I think the first proposed stage is to stop generating new tokens. I think 124, the oldest supported kubelets, are a version that would be using bound service account tokens, probably +1 version actually. So at that point, all pods that are running in the system would have been created on an API server version where bound service account tokens were in use. So at that point, we no longer need the auto-generated ones to mount into pods.
Okay. A related question to all of this. So to the related question related to the explicitly requested stuff, which I know we've said isn't really in this KEP, but as a possible approach, would we consider approach? So like today you put an annotation on a secret, or yeah, it's on a secret, right? Yeah, you say I want it injected here. I think that's how it goes. Would we consider adding a sibling annotation that means basically that would be ignored by older API servers? So on a old API server, that structure would mean I want a long-lived non-expiring service account token. But on a newer API server, it would mean I just need you to fill this out with token request for me with a whatever lifetime. I'm equipped to do the refresh off of my disk. But I need it in like a specific like do we care about that specific case, or is that just like whatever?
I have a hard time envisioning a use for that.
It's because you can statically encode that in a manifest. It's basically saying, hey,
but but if you want to, so the use I can see for secrets, there are two uses. One is API clients that are going to make an API call to get the secret. If
Yes.
they're going to make an API call to get the secret,
Yeah,
I would recommend they make the API call to token request directly.
Yeah, and that's totally fine.
The other use case is so that that secret can be mounted into a pod. And if you're going to do that, we have service account token projection, so you can write it directly into your pod manifest.
Yeah, the case that I care about is I need the same manifest to work across, like from Kubernetes 1.17 to 1.23. Right? It's I want to do the best thing that is possible based on the environment I'm in. I just don't happen to know that up front. I can see that's an edge case, and maybe I'm the only one who gives a crap.
It's a long skew.
Yeah, but that's the skew I currently support. So
yeah.
So I'm not saying that it's not a long skew. I also happen to live in that world right now, so I'm not like particularly like saying that it's a bad thing to do. Right?
I don't think I would be in favor of adding features to like 124, 125 timeframe that are pretty much the only use case I can see is to support a manifest that works back more than a year and a half. It's, I think, 121 and up. So by the time this was enabled by default, it would be 125. So like 6 version skew, I think is kind of weak for that.
When was token request GA? Was it 121?
121.
Yeah, so I mean, yeah, like 121 is still quite new when you're like deployed on the cloud providers, right? Like 117, 119 are quite common there. Like that's kind of what I mean, right? Like the bleeding edge of Kubernetes and what the reality of Kubernetes are kind of different things.
I think my perspective on that is if you have to support very large skews, you likely will also need to have different manifests.
Yeah, which is fine. I mean, I can tolerate that if I have to. I already have a ton of spaghetti handling a bunch of Kubernetes versions. It's just this one is harder because it's at the manifest level and less at the API level.
I thought you were going to ask. I thought what you were going to ask was, so what are we going to do about the manually generated or manually requested tokens? Are we ever going to find a way to make those not be eternal tokens?
I don't think there is an answer to that. If you're using them as eternal tokens, the only thing we can do is break you. And if we're willing to break you, then we can break you right now. But I don't think we are. Like nothing changes in a year from now. We're still not wanting to break you.
So I think what could change is understanding how prevalent the use case is, which I don't think we have a good understanding of right now, and also offering easy to use alternatives. So both of those things could change. I think we should challenge ourselves to figure out what the end state is. I don't think we necessarily need to do that for an alpha feature, but as we kind of approach beta and GA, I think like removing the majority of tokens from the API is helpful. It's definitely a boon to security. I think the one thing that is still challenging is the ability to rotate service account signing keys, which we don't get until easily until we have an alternative to using them for service account forever tokens.
I mean, if we wanted to help make that automatic, right? There's no reason that we couldn't have support for automatic rotation, but with no expiration of old public keys, right? Like you can keep making new signing keys and using them. You just can't get rid of the old ones, right? And so I mean that's still moving the bar at least a little bit forward. And you can the admin could decide if stuff gets put out the trust one.
Yeah, I think without expiring old keys, the benefit there's going to be limited.
Yeah. I mean, to be fair, I wish these didn't exist. I wish they'd never been made, so that way no one could have relied on them. But can't go back. David,
Okay.
I see you unmute.
I was just going to remind you that it was Jordan's fault. And if they hadn't been so useful, we wouldn't be in the situation. So,
yeah.
I would like to, 5 years later, make excuses for myself and say that my first proposal was actually an endpoint on the API server that you could request tokens from, and so they would never hit the API. But that was considered too complex at the time. So I should have stuck to my guns. But
that's wonderful. Cool. All right. Anyone else have thoughts, comments, concerns?
I think I have the AI on the current kept from Jihang. So last I looked, most of the comments were addressed. So I expect that to kind of merge more or less in the current shape. I haven't done a final review, but if you have comments, please jump in. The test case, the question about token reviews and authentication chains, that's a good one, David. If anyone else has any comments about that one, jump in the next few days. Probably look to merge that sometime next week.
Cool. All right. Okay, so I think all we have left for the rest is the KMS stuff. So I can give a quick update. So Jordan and David, you were there last week on the API Machineries meeting, but as a very quick recap. So I had asked the question of could we formalize the subset of the etcd API that we use, so that way it would be easier to build like a shim for it. Response was, well, the subset of the API is the whole API, which is fine. So what that leaves us there is if we wanted to build a shim layer, the responsibility would be on to us to implement the whole etcd surface area. Just that surface area is quite large. The tiny bit that we use in Kubernetes is not large at all. It's actually quite small. So thinking through that, though, it seems like it would be a strange thing for us to do. I mean, it might be plausible, but it seems a little strange to depend on a like an unbounded API set that can grow over time. Maybe it's fine. I don't know. So Anish, I know you have a proposal out there. I guess I think it's from both you and Rita. And I've been trying to think of what our next steps are. I think my overall hesitation is a lack of operational experience with what the shape of such an API would be and sort of like how we expect it to behave like in the real environment. I think like the pain points of KMS come from that it was just sort of, it was built without running it. Now when you run it, it does weird things in certain subsets of cases, right? I'm also not fully sure how much of like the lifecycle stuff we'll be able to preserve. But as an approach, and I'm looking for feedback from like the SIG leads and the Anish and Rita and stuff, is should we try to, just like experiment like in tree, but not like with merging anything, just like experiment in the Kubernetes code base with like experimental versions of the existing KMS plugins that exist for the cloud providers. So basically make changes to those both components and try to solve the problems that we know exist. Probably the hardest one being like the lifecycle hook stuff when the key's gone. And I know Rita had mentioned that cloud KMSs have concepts of locks on like keys, so like maybe we should take advantage of those. But basically, I'm kind of thinking of like a a beta 2 gRPC API that is radically different than what exists today, and maybe it's like a V2 alpha one, not even a beta 2, like it's a complete it's a completely unrelated thing. Sort of explore and see if we can solve the problems. You folks have thoughts?
Yeah.
Sorry, I'm
Yeah.
trying
So,
to.
do you think we should start with GA graduation requirements, or do you think we're too far away from that and we need to do some, like, fundamental introspection before we proceed on the current implementation path?
Yeah, like what I'm unsure about is like what is like sort of technically possible. Like what could you, like if you have complete code level changes controlled on internal Kubernetes and KMS plugins, what is the maximum state that you can reach for the perverse cases of KMS, like, and like how well can you tolerate these failure modes? I'm not sure what the edges of those are. I kind of want to explore those to try to understand like what are reasonable expectations for the GA of this. I mean, we could say that all the problems that we've identified so far, all of them have to be perfectly solved effectively, and that's what it takes to GA. But that might set the bar to a point that it's effectively unreachable. Right? Like some of these might not be attainable. And
Shihang, you have a lot of experience, at least with GK's implementation. Are there anything that jumps out at you that you would say, yes, we should change this if we're going to take an opportunity to make changes?
Yeah, the one thing is the scalability, right? Because we introduce another like external call. So when we do the secrets, when we read the secrets from the etcd, we are doing like serialized, like, for example, the watch cache, they have a page size 1000, but yeah, 1000. You're gonna make serialized 1000 calls to the external cloud KMS, which is the latency is pretty large. Sometimes we had issues that the watch cache will fail to initialize because of the first list of the secrets will, like, because there's a resource version associated with each the list call, right? So it just expires, which in this case the watch cache doesn't initialize. So I think the scalability issue that we probably can solve in the open source side. There are, like, for example, we can do we can introduce a cache or paralyze the calls, and also expand the API to introduce and add some. I don't quite remember what I proposed that last time. Basically, we're gonna change the APIs. So that's the only thing that I can think about graduating the API to GA. It's the scalability issue that we probably can solve before that.
David, you want to go?
Yeah, I am concerned about how to handle undecryptable data. That's one that I think we need to solve before we consider GA, because right now you can't list anything is really bad. And while that data is gone right now, I could see someone saying, oh no, maybe I have a backup of it somewhere, and trying to bring it back somehow as an action. So I'm also not sure just call it deleted is correct either.
David, have we ever, or you or anyone else, have we ever considered trying to separate some of the like lifecycle hook metadata from the actual payload? Like,
So 7 years ago, we had this idea that we might want to use etcd to store two different records, a metadata record and a spec record and a status record. We never needed to do that for scale. So I'm going to say realistically, no, nobody's looking at it.
I mean, I'm almost thinking of like if you like, I'm trying to think like owner references, finalizers. There's probably some other stuff I'm forgetting, like API semantics. I was trying to think. So I admit I hadn't thought of the restore from backup case. Like you have encryption, like you either have an encrypted backup or a decrypted backup, and you want to somehow try to reinsert it, overwriting encrypted data and thus restoring functionality. I thought of that. That's even like a more edge case of an edge case than I'd expected.
So I think what we ran into when we started thinking about like what would it look like to separate out metadata, especially like finalizers. Owner references, I could maybe see, but finalizers are just a string, which is like, here's the list of things that need to participate in teardown of this object. And usually finalizers need other information from somewhere else in the object to do their thing, right? Like if they're tearing down some external system or they're whatever it is, like, and so a finalizer controller is going to be watching for objects and paying attention to ones with a deletion timestamp with its finalizer string in the list, and then acting on those objects. And so it was never clear that just having metadata separately available would be enough to like actually let finalizers do their thing.
Yeah,
but I agree with David. Like the two, well, we're talking about like GA requirements. I think that's a good question, Mike. And I don't know if it's particular to this implementation, but saying like, what would it take for this to be GA is a good question. And then once we have those, we can look at the current implementation, say like, is there a roadmap to get this there, or does some of it need to start over? But like the scalability issue, I think is significant. Secrets in particular will probably be helped a lot if we stop auto-generating service account tokens for every service account and every namespace. But I think the scalability issues are still there if you have enough secrets of different types. So the scalability issues.
So if I could make one comment on that, like I know it's not easy to express in our API, but we could certainly make it easier to express. Like I feel like you should be able to ask, please encrypt everything. Not just secrets, not just config maps, not random tokens, just encrypt the world, because I don't know and I don't want to know. I don't care. Just encrypt everything, right? And to me, it should work in that state. Like if every single call has to decrypt data, it should still work in that state at like some reasonable scale. Maybe the bar is too high, but to me, it should work.
Well, that is certainly a higher bar. I think the minimum bar would be the one resource we tell you that makes sense to encrypt. If you create like what we say is a normal number of namespaces or a supported number of namespaces, the supported number of objects, that shouldn't explode.
I mean, that's just in vanilla Q, right? Like if I'll take OpenShift as an example, right? There's tokens everywhere that should be encrypted at rest because they should be.
Yeah.
Why not?
So scalability, I agree. The undecryptable data story, I agree with David. Like we have to have some recourse there that is not like throw away your cluster, which is sort of what is there today. And those two seem like the biggest ones to me. Now, to meet those two may require changing how we talk to KMS, and may require, may require changes in the implementation, but those seem super important. I would be really interested to hear from the people implementing KMS integrations. We sort of hand waved around like how do you integrate with a KMS lifecycle, key lifecycle, and just sort of said, well, we assume people implementing those will figure that out, and that may or may not have been true. So I don't know that that's necessarily on us to solve, but I think we should at least make sure that the people we're saying should be solving that have what they need from us to do it, whether that's some changes to the KMS API or changes to the decryption config, or we should at least be closing that loop and making sure those problems can't be solved, because they're super important problems. And if they don't get solved by anyone, then the feature isn't really usable.
My recollection, and maybe Shihung can elaborate, but yes, the lifecycle issue is pretty big, at least in our implementation. We've got a lot of, I would term it as hacky assumptions around key versions and stuff. Maybe I'm thinking of a different thing when you say lifecycle versus.
No, that's what I mean. Like a key starts getting used in the KMS, and then like eventually it gets rotated out or retired, and there's still stuff in Cube using it. And so we sort of hand waved and we're like, oh, we'll change your config and then touch every object in the system. That I can imagine that working, but when you couple that with like the performance issues around touching every object in the system that's encrypted, it didn't really work. Plus, there weren't good ways to find out, like, to easily find out what keys are we still using. So if you did want to do an integration with KMS to say like, don't let this key be dropped until the data encrypted with it has been re-encrypted with the next key, like there wasn't a good way to answer that question.
So when I mentioned like storing like data separately, what I was imagining though was like a structured payload, but still one single value in etcd, and like part of the structure would need to be something like key ID. But I was also imagining you could have a section that was purposely like only references or whatever, like that was separated out as a way of saying I could reconstruct part of the object if you asked, because I know how to do that part, but I can't do the rest because it's encrypted and I don't know how to decrypt it. I don't know if it fully helps. Like I fully understand that like if a finalizer relies on the encrypted state, then the controller probably can't do anything useful. I mean, maybe it can go ahead and remove the finalizer, but it's not our code to fix. Someone else has to.
Right. If we're just going to remove it, like, yeah, I'm not sure what we would serve in a list or a get. Like for something to act on it, it still needs to be able to get an update. And if we've dropped all of the object except like these few narrowly defined, probably reasonable to not encrypt fields, then like when we serve a get of that object, we're not even serving a valid object.
Yeah, like it might it might be semantically valid from the Kubernetes API validation, but not valid for what the actor that originally stored it is. Right? They might have a controller that implodes on itself because it expects the field to always be set, and then like has a runtime panic or something trying to use it. Yeah, those are the bits I find harder to figure out that if they're reasonably addressable. Like I do think we could expand the API and make it easier to express the concepts of rotation and stuff, especially with like if you had some way to have like a multi-leveled config for the same KMS integration as a way of saying that like these things are related and they need to coordinate with each other in some way. Maybe I think that could make it somewhat easier. I'm not exactly sure how far you actually get with the 5% of the object that we can keep unencrypted. I mean, we could certainly allow you to delete it. We could totally add hooks in to the API that say if you pass some parameter in your delete request, it's a way of you saying delete even if you can't decrypt. Totally make that work. I don't know if that's what we want. I don't know if that's a sound thing to do because it sounds like
we should definitely have the sixth way to say force. Now, grace period 0, force, and whatever the fourth one. I didn't have a solution offhand. I just know that it's on my pain point for the current API.
Yeah, no, I don't think especially for platforms that are like KubeADM or OpenShift that are self-hosted, they should ever run this functionality without us doing some fixes. Because the control plane is very reliant on a stable API surface, and this turns it completely unstable.
I assume the deletion part is configurable, right? I mean, we can decide on a default behavior, but we should make it configurable such that if they don't like the default behavior, they can always opt out or opt in, however we want to do it.
I mean, what is the default behavior, Rita? I don't even know what default behavior you're referring to.
I'm talking about the delete, like undecryptable data, right? We talked about deleting if you can't decrypt.
Yeah, I mean, so I mean, I don't know, like if you have delete permission on an object and you've gotten past the whole authorization chain and the admission chain or whatever, and it's fine that you delete the thing, no matter if you can decrypt it if you want it gone. I mean, maybe it does, because if you set preconditions, you're saying, hey, delete only if it looks like this. But if we have no idea what it currently looks like, how do we know that your delete precondition is being met?
Yeah. So I mean, that's one possibility. So when you configure the encryption, you can decide what happens when stuff is not able to be decrypted. Dropping undecryptable data means violating finalizers and stuff like that, which is bad, but breaking your cluster is also bad. I think if we were going to do something like that, we would need a much more definitive answer from the KMS that not only did this particular decryption request fail, but it failed, and I know that the key is gone and it's never coming back, and it's like permanently failed. This isn't a blip. This isn't the key. I couldn't look up the key, but try again later, because we definitely don't ever want to be dropping data based on transient errors. But if the KMS can definitively tell us, like, the key is gone, this will never be decryptable, and I guess the cluster admin maybe says, if I get permanent decryption failures, then drop the data. I don't know. It's not great, but nothing seems great in that scenario.
I mean, if we couple that, whether it has a config or not, I'm not sure if like the config makes sense, but if we couple that behavior with a stronger tracking of keys and a way of trying to have a much tighter coupling with the KMS by saying, hey, KMS, I am using this key, and the agreement you're making with me is you are not going to drop it. So you dropping it and returning me the unrecoverable key error is you being like a really bad KMS, right? Like you're not actually like doing what you told me you would do. But maybe the reason the KMS did that is because the root admin guy on the cloud account said, no, I really need this key to die. Then, okay, fine. The key goes poof, and it violates the constraint that Kubernetes has. But if you have both sides of that, right? Like if you have a good contract, and that case should basically never happen in a well-behaving system, and it only occurs in a misbehaving system, and then also has to be explicitly told to us by the KMS, maybe it's fine to drop it and violate the Kubernetes constraints, because the alternative is all lists fail and all deletes fail and the cluster doesn't work. Like vague middle ground of like not completely bricked cluster.
So I think, you know, obviously deleting a key and stuff being unrecoverable is working as intended. It's interesting to think how this conversation would change if we were encrypting the entire disk that etcd was stored on, or if we were doing what you mentioned earlier, where we were encrypting all objects, where it would be kind of obvious that deleting the key totally messes up the cluster unrecoverably. I don't know. How deep do we need to solve this? Is it going to be like object dependent heuristics based on specific resources, need, I guess, more advanced finalization, or, you know,
I mean, what I really want
like
is for the integration to put a, like, when a key is in use, there's a lien on the key in the KMS that says this key can't go away because it's used in this cluster. And before you get to delete the key, you have to, like, there's enough information and for the integrator to like say, okay, the key's no longer in use, like drop the lien. Like that's really what I want. I don't want this to be our problem to solve.
Right, exactly. That seems reasonable to me. I don't know how well we can actually do solving this ourselves.
Yeah, so that was the first part of it, right? Like it was that we would make it effectively nearly impossible in a well-behaving system for this state to occur because we are tracking the information to say the key is in use by us. Please don't delete it because you are going to destroy this cluster in some subtle way, right?
Occur accidentally.
Say what?
Occur accidentally.
Yeah, so if it somehow manages to occur because of a bug on a human's part or whatever, do we need to care about that case? Maybe. I mean, like, you know, if a different approach to deleting stuff could be, I don't know if etcd has a move operation, but we could move it somehow, like move the encrypted data into a different part of the tree and effectively delete that key, but leave it around as a way of saying, well, we can't do anything with it anymore. It's just, we're just going to stick it over there. If you happen to later find your decryption keys, you can go decrypt it and get it back, but that's on you. So we are out of time though. So I think we can leave it here. Anish, Rita, I think we do have some good next steps, so I think we can start working towards poking around with what's possible. But we'll see y'all in 2 weeks. Yeah.